confidence intervals. Confidence intervals estimate or are designed to try to estimate some unknown value. And so before we can construct confidence intervals, we need to understand how to construct or how to calculate a critical value. And there's several ways to calculate a critical value, and I'm going to show you some. So for a 90% confidence interval, so let me explain what's going on here. Let you visualize this. I'm going to draw a normal curve. When I'm talking about a 90% confidence interval, I'm talking about the middle 90% of the curve. So the middle 90% of the curve. What you have to do is you have to determine what is this z value. They call it z of c. What's this z value at the top end of this boundary? What's the z value at the top end of this boundary? So let's ask ourselves, how much area is at this point and below? So what percent is at this point and below? So we know that this part's 90%. Now let's ask ourselves, what's this part is also included? What percent's in this tail? 5%, right? Because we have 90% there, and there's 10% left over, so it's 5% in each tail. So that means that 95% is at this point and below. So now what you have to do is you have to figure out what is the critical value for that point. So you could use the z table. This is a little outdated, and you could go look for 0.95. So z table and go look for 0.95, and you find it's between 1.6, 0.95. It's close to here. So 1.6. 1.64, 1.65, so it's somewhere around there, 1.64 to 1.65. Now, I think that's one way to do it. Here's another way to do it. Another way to do it is to use inverse norm. Okay? So I'll go to second bars, inverse norm. Now, area. You could talk about the area to the left of this or the right of this. What's the area to the left of this point? 95%, right? What's the area to the right of it? 5%. So do y'all want to use 0.95 or 0.05? Doesn't matter. I use 0.95, 0.1 in left. Or I could use 0.05, 0.1 in right. Okay, and I do this, 0.95, 0.1 left. And I get 1.6, around 1.645, okay? And that's really the one I would want you to use, okay? I like this one because it gives you more an exact value. Okay, you don't have to use the z-table. The z-table's not always convenient for you as well. So that's how we find a critical value. So let's look at 95%. So from this point forward, do you want to use the z-table or do you want to use inverse norm? Doesn't matter. Let's use inverse norm. So we got 95%. Now you might be able to visualize this in your head. Let's just talk about this. If 95%'s in here, what's outside of here? 5%. So how much is in each tail? Yeah, 2.5%, half. So half's in each tail. And I need to know the z of c at this high end right here. So I can use inverse norm. Now with inverse norm, one thing I didn't mention is the mean and standard deviation is 0 and 1 for the standard normal distribution for the z distribution. So this is going to be 0 and 1. Now, do y'all want to use left tail or right tail? What do y'all want to do? You could use the right tail. What's to the right of z of c? What percent? Yeah, 2.5% or 0.025. So 0.025 is to the right of it. So you can go 0.025 to the right, or you could use 0.975 to the left. Okay, so whatever way you want to do. You don't really have to show your work here. I'm just doing this all so you can see what I'm doing. I'm going to say 1.96. Say around 1.96. Okay. Do you want to do what's at this point and below or what's at this point and above? What do y'all want to do this time? Above. So that sounds good. What's this area if it's 1%? What do I put? 0.01. Yeah, good. 0.1 right. So 0.01, 0.1 right. I can do 0.99 on the left. So 2.326. I'll say 2.33. 99%. Going a little faster now. So 99% in the middle. Z of C. Whoa, didn't mean to put that there. So that means there's 1% not in there. That means 0.5% out here. 0.5%. You want to go left or right? Doesn't matter. Right. So what's 0.5% as a decimal? 0.005 because you move it over 2 spots. Or you can use 0.995 and left. 0.005 right. 2.575 or 2.58. Okay. Now, what I want you to know too is for a Z distribution. Now we'll do some T ones tomorrow. When the population standard deviation is known, you'll use a Z distribution. And for Z distributions, these critical values will always be the same. So if you're doing your homework, you don't have to calculate these. You could just go look at this chart here because these are the most common ones that you're going to see. You probably won't see anything outside of this chart. So we do our homework, we'll just go to this chart.